So one last little thing here, guys. And I appreciate you making it through this lecture every day. Let's see. And I'm going to do this conceptually and then mathematically. One thing we haven't talked about yet, we've talked about or, we've talked about given, but what keeps showing up in both of these stupid equations that we don't have a formula for itself yet? And. What the hell is a formula for and? So let me give you a situation. And I just like this setup. I don't know why I came up with it at one point. Let's say you want to join a sorority or a fraternity. And their hazing that you have to go through is that you got to walk down this really long hallway, and every 5 steps you take, somebody slaps you on that cheek. And every 9 steps you take, somebody slaps you on that cheek. So what's the probability I'm going to get slapped on that cheek? Take a really long walk.
More than.
What do you think?
Steps, twice as
I'm going to get 1 slap for every how many steps?
5.
5. So there's a 1/5 chance of that, right? You with me? So what was that? That's my left cheek. That's my right cheek. I got to do this. To be honest, that makes an L, so that's left. So that's right. Probably the right cheek is 1 every 5. What's probably the left cheek?
1 over 9.
1 every 9. How often am I going to get hit on both cheeks? How often am I going to get this happen? Shit. How often is that going to happen? 5 steps, bam. 9 steps, bam. When is it going to happen? I'm going to get this.
45.
On the 45th step. What operation did you use? Multiplication. 5 times 9 is 45. You guys with me? That's what you also know as the least common multiple of those two numbers. But, and of course, don't get too deep into this with non-prime relatives. Screw that. This is the idea. Multiplication. Or is basically add. The given is an idea. And is basically multiply. What's the probability I get both? It's going to be 1/5 times 1/9. 1 for every 45 steps. You with me? Does that make sense? Can you visualize that? Somebody getting slapped here, slapped there. And very infrequently, both. In fact, this frequently. 1 out of every 45 steps. Cool. So the probability of and is somehow related to multiplication. But I haven't filled those in yet. It's not probability of A times probability of B to tell you honestly, because the setup I use is very basic. There are things that can happen to make it a little more complicated. So let me show you an example. So if I pick 2 cards without replacing it, so I pick a card and then I feed it to my little brother, or I throw it away, right? And then I'm going to pick another card. I want to know what's the probability that I get a king and then another king. So the way this is going to work is it's exactly the same as what I'm doing here, except something weird is going to happen on the next step. So when I multiply those two things, the dude that's going to hit me on the 9th step, he doesn't care how many steps I've taken, really, except that I've taken some multiple of 9. He doesn't care that I got slapped on this cheek so many times. He's going to slap me every 9th time. 18, bam. 27, bam. Right? He's just following me around and hitting me every 9th step. He doesn't care what the hell the other person is doing. But here, if I take the first card out and throw it away, what's going to happen to the second king's chances?
Increases. No, it's going to go down.
It's going to go down. If I get a king on the first one and I throw it away, probably going to get a king on the second one. It's going to have to go down. What's the probability that first one's a king?
1 out of 13.
Let's be less specific. Let's be 4 out of 52. Trust me on this. Because now, what's the probability of this king given that I picked a king on the first try?
3 out of 51.
Yeah. 3 kings left out of how many cards left? 51. You guys with me? And the reason I've got to worry about that here is because physically what's going to happen if I take a card out and throw it away? There's a 4 to 52 chance it's going to be a king. So what's left for the next king? 3 out of 51. If I did it again and got wanted another king, what's the chances of another king happening? 2 out of 50. Cool. And then this will be whatever the hell it is. So that's 1 out of
289.
22.
89.
89?
That's what I get.
Probably right.
2,621. What?
It's 221. Anyway, doesn't matter. You guys are good at decimal, yeah, that's fine. So what about this though? What's different if I do it with, let's say without replacement. Let's do a different example here. What about king and an 8? So what's the first card I'm going to pick? What's the first card I want to pick in this setup? King. What's the chances of that? That's of course 4 out of 52. Without replacement, I throw it away. What's probably I get an 8 now?
4 out of 51.
There's still 4 8s, but now there's 51 cards. So notice, why did this number go down? Because I was getting a king and then another king, and I threw the first king away.
So now your chances increase of getting that 8.
Yeah, exactly. Now the chance of getting an 8 on the next card has gone up a little bit because they've thrown out one other option. Okay, a little bit. All right. So we're definitely going to cover this a little more in depth. I had to kind of throw it in there at the end here. So remember, next time we will probably start off with a few more examples of this, and then I'll let you guys work on this practice probability quiz together. So not a lot of lecture next time, thank God. All right.